Welcome back. Today we're doing a deep dive into something, well, pretty unique actually. It's a source called Use and Abuse of Energy in Climate Scenarios. A week of controversy on scenarios. And what makes this study so unusual is that it's basically a documented email fight. A back and forth between two major figures in energy planning happening over just 6 days back in June 2018. You just don't often see that kind of raw debate published.
Exactly. It's quite something. On one side, you've got Michael Jefferson, a real veteran, helped set up early scenario work for Shell for the World Energy Council.
And on the other,
Christian Breyer, he's an expert really focused on the solar economy, pushing for 100% renewable systems.
okay, so two very different perspectives clashing.
Absolutely. And our mission here for you today is to unpack this really lively exchange. We want to understand why energy and climate scenarios are always so controversial.
Because they're not just numbers on a page, okay?
Not at all. They guide huge decisions. Investment, what fuels a country uses, international deals. I mean, the stakes are massive. They touch on fundamental strategic issues. So, yeah, controversy is kind of baked in. So let's start with Jefferson's approach. His foundational view. He believes scenarios can be really useful, especially for the long haul. Think over 20 years.
Right. He mentioned one from Shell in 1974.
Yeah, astonishingly, he said it was still robust 44 years later. So for him, it's about providing that long-term foresight, not just a single prediction.
Okay, but what makes a scenario robust? How does it last almost half a century?
According to Jefferson, it's all about the building blocks being really clear. You need to explicitly lay out your assumptions: geopolitics, societal trends, economic conditions, financial stability, all of that.
Without that foundation, it's just guesswork.
Pretty much. And here's a key strategic point he makes. You absolutely have to take seriously those scenarios that seem unlikely but, well, could have huge consequences if they happened.
Planning for the big shocks, not just the most probable path.
Exactly that. Preparedness, not prediction. But, he's also quite critical of the field itself. He says, looking back, global energy modeling has often been, and I quote, generally disastrous.
Wow, okay. So he wants people to admit the track record isn't great.
Yeah, recognize the past failures. And instead of these massive try-to-model-everything systems, he actually prefers what he calls mini-modeling. Smaller, focused models. Use them to test specific issues, see how things might react under certain stresses. It's a different philosophy.
And he also brings up things like past energy transitions, behavioral factors.
Right, things like the rebound effect or the comfort paradox. These human elements.
Can you quickly explain those? What are they?
Sure. So the rebound effect is when, say, your car gets more fuel efficient, but because it's cheaper to run, you end up driving more, so you don't save as much energy as you thought.
Ah, okay. Makes sense.
And the comfort paradox is similar. Technology makes air conditioning cheaper, for example. So instead of just cooling to the same level for less energy, people might decide they want their house even cooler, using more energy overall.
So human behavior messes with the purely technical predictions.
Often, yes. Jefferson argues you ignore these factors at your peril.
Right. Okay, so let's bring in Christian Breyer. His take sounds quite different, driven by more urgency.
Definitely. Breyer's starting point is climate change. He argues the constraints are now so strong, so undeniable, that they basically dictate the future, meaning a very steep decline for fossil fuels and nuclear power. It's unavoidable in his view.
And here's where it gets interesting. He suggests that maybe making future scenarios is actually getting easier. That seems counterintuitive.
It does, doesn't it? But his logic is, if the endpoint is fixed, we have to get to near 100% sustainable energy, then maybe that simplifies things, reduces some of that uncertainty Jefferson worries about.
Coupled with better data from places like China and India.
Exactly. Those markets are moving so fast on renewables, we understand them better. And to back this up, Breyer points to his own track record, specifically with solar PV projections.
Okay, what did he claim there?
Well, he claimed he was basically alone in getting the cumulative PV capacity right for the end of the previous decade. He said back in 2011, his projections were 600 gigawatts pessimistic, 1,000 gigawatts realistic.
And how did that compare to reality?
The study notes the actual number was 400 gigawatts at the end of 2017, but it was heading towards maybe 750 plus by end of 2020. So, while not spot on, his numbers were certainly much, much closer than the forecasts from major institutions at the time.
Which leads him to really attack those institutions, right? The IEA, EIA, the big oil companies.
Absolutely. He
Yeah.
doesn't hold back. He says they've been terrible wrong in the last 10 years on solar growth. He specifically calls out the International Energy Agency, the IEA.
What about the IEA?
He accuses them of essentially denying the reality of exponential growth for PV for something like 20 years. He even says their reputation is ruined in the PV community. Pretty strong words.
That is strong. Were the forecasts really that far off?
Breyer gives a really stark example. He points to a paper in the journal Energy Policy from 2009.
Okay.
This paper claimed the absolute lowest cost solar PV could ever reach would be 2,100 euros per kilowatt peak in the year 2100.
Wow. So basically saying it would stay expensive for the rest of the century.
Right. But by 2018, when this debate was happening, market prices were already down around 600 or 700 euros per kilowatt peak.
Already way below that supposed floor.
Way below.
Yeah.
And he suggests the real floor cost might actually be under 200 euros. So in under a decade, the market completely demolished what that paper claimed was a century-long cost barrier.
And Breyer's implication is that such forecasts weren't just wrong, they were maybe intended to slow things down.
That seems to be his view, yeah. That they were used to justify sticking with fossil fuels in scenario planning.
Okay, so this massive cost drop, that brings us to another point of friction in this study. Who gets the credit? Jefferson pointed towards China, didn't he?
He did, reflecting some other analysis out there about China's industrial scale-up being key.
But Breyer disagreed.
Strongly. He fires back, quote, "Not the Chinese killed the PV cost, it had been the Germans."
The Germans? How so?
He credits Germany's energy transition policy, the Energiewende. It created massive guaranteed demand for solar PV early on. That demand stimulus, he argues, is what really kicked off the steep learning curve, driving initial cost reductions.
So Germany created the market that allowed the technology to mature.
That's his argument. He calls it the most valuable development aid Germans ever donated to mankind. Bit dramatic, maybe, but you see his point. China then came in later with huge supply-side investment, driving costs down further. But Breyer says Germany lit the fuse.
That's quite a claim. And it connects to another disagreement, right? About the cost of Germany's CO2 reduction.
Yes. Jefferson cited some figures, reportedly from the IEA and Ruhr University, suggesting the cost of avoiding a ton of CO2 via Germany's PV rollout was incredibly high, like 715 to 1,000 euros per ton.
Which sounds really expensive.
It does.
Yeah.
But Breyer completely rejects that way of calculating it. He says PV doesn't have CO2 reduction costs. It provides CO2 reduction benefits.
How does he figure that?
Because, he argues, the cost of the energy itself is falling while you're reducing emissions. So you get cheaper energy and less CO2. It's a win-win, not a cost burden, in his view. It's a fundamental disagreement on methodology.
Clearly. The study also mentions a technical debate, something about ERO-EI, energy return.
Energy return on energy invested. ERO-EI. Yeah, it's basically asking, how much energy do you get out from a technology like a solar panel, compared to all the energy needed to make it, install it, maintain it, and eventually dispose of it?
Okay, a basic efficiency measure. Why the controversy?
Well, it gets complicated fast. The study mentions a specific paper, Ferroni et al., that Breyer and a bunch of co-authors really went after. The fight is often about system boundaries.
Meaning, what energy inputs do you count?
Exactly. Do you count the energy used to mine the silicon, build the factory in China, transport the panels? Depending on where you draw those lines, the final ERO-EI number for PV can vary wildly. There's considerable divergence, as the study puts it, and real fights within the research community about the right way to do it.
Right. Okay, let's shift gears a bit. Breyer also brings up corporate history, specifically Exxon and Shell.
He does. He makes a pretty bold claim that they've known exactly what happened and will happen with climate change since the early 1980s. He even points to a 1988 Shell internal report.
And his conclusion from that.
If they knew that much that early, then there's simply no excuse for not acting much more decisively on climate policies over the subsequent decades. Now, Jefferson pushes back a bit here, or at least adds nuance. He doesn't fully dispute the timeline of knowledge, but he does differentiate between Shell, the global Royal Dutch Shell Group, and Exxon.
How so?
He mentions internal politics. Apparently, Shell's U.S. division, Shell Oil in Houston, was actually a member of the Global Climate Coalition, the GCC. That was a group known for aggressively lobbying against climate action.
That's awkward for Shell.
Extremely. But Jefferson makes a fascinating point. Because the GCC was so extreme and out of touch with the science, it paradoxically helped the wider Shell group pull the U.S. division back towards a more responsible stance eventually. He also adds that personally he never met anyone inside Shell management who was an outright climate denier.
Interesting internal dynamics. But Breyer's focus is on the outcome, the delayed action. He compares them to tobacco companies.
Yeah, he says he hopes the big oil companies get punished as the tobacco companies, which also blocked progress for decades.
And he sees signs of that happening. Legal challenges.
He mentions New York City suing major oil companies for climate damages as an example. He suggests the tide might be turning, that courts could start deciding what corporate responsibility means in the context of climate change.
But Jefferson questions that liability argument, doesn't he?
He does. He concedes Shell reacted too slowly, insufficiently, and with too much of a time lag. But then he poses a challenging question. If companies like Shell did publish warnings for 30 years, and the public, energy consumers, largely ignored them and kept consuming, where does the blame really lie?
So he suggests maybe the responsibility isn't solely with the producers.
He raises the possibility that culpability might need to be shouldered by the vast majority of energy users, too. It's a provocative thought about shared responsibility.
Definitely something for you, the listener, to think about. Where does that leave us in terms of solutions, according to Breyer?
Well, Breyer sets a high bar. He says the goal has to be a truly sustainable energy system. And that means rigorously checking if components meet sustainability criteria. If they don't, they need replacing.
And importantly, not all renewables automatically pass that test.
Exactly. He specifically calls out things like new palm oil plantations for biofuels or environmentally damaging hydro projects like Grand Inga as examples of renewable solutions that might not be truly sustainable.
So it requires critical assessment even within the green transition. What about future fuels then?
He's a bit skeptical about biomass, generally points out low efficiency in land use, potentially poor EROEI, especially for crops grown just for energy, though sugarcane does okay.
So if not biomass, then what?
He thinks the clear winner could be synthetic fuels and chemicals made using renewable electricity. Things like Fischer-Tropsch fuels.
How does that work?
Basically, you use cheap renewable power, and he highlights solar PV tenders hitting incredibly low prices, like $20 per megawatt hour or even less, to split water into hydrogen. Then you combine that hydrogen with captured CO2 to synthesize liquid fuels or chemicals.
So using cheap solar power to create liquid fuels that can replace oil.
Essentially, yes, renewable electricity-based hydrocarbons. And because PV is getting so cheap, the economics are starting to look really attractive.
And this ties into his idea about North Africa, a kind of desert tech reloaded.
Sort of. He wasn't keen on the original desert tech idea of just shipping electricity long distances via massive tower lines.
Right.
But he sees a huge opportunity for regions like the Maghreb to use their incredible solar resources not to export electrons, but to produce these valuable synthetic fuels and chemicals locally.
So they'd export fuel, not just power.
Exactly. A high-value, sustainable export product, creating a potentially very attractive energy future for that region. So, this whole week of controversy captured in this study, it really highlights the core challenge. Planning for the future is incredibly hard. You've got natural uncertainties. Jefferson mentioned things like solar minima potentially affecting climate, plus these incredibly rapid technological shifts Breyer focuses on.
Like the PV cost plummeting.
Right. But despite the difficulty, doing this scenario work is absolutely essential, isn't it? Because the risks we're trying to manage, like climate change, are existential.
And that uncertainty never really goes away. You mentioned Jefferson pointed out that even IPCC scenarios can be off.
Yeah, it's a sobering point he made. Apparently, 111 out of 114 favored scenarios in the IPCC's fifth assessment report were already, at the time they were published, overstating warming compared to observations back then.
Which just underlines the need for constant reevaluation, right? Continuous review of the scenarios.
Absolutely. And that review process directly impacts really practical decisions being made right now, like where we should optimally be placing renewable energy facilities around the world.
Well, we hope this deep dive into the use and abuse of energy and climate scenarios, a week of controversy on scenarios, has given you some useful insights and maybe some tools to think critically about the energy forecasts and debates you encounter.
It's certainly a complex field, but understanding these clashes is key.
Indeed. Thanks for joining us, and we'll see you next time.